So this is the first question. In this we proved function is continuous at x equals to 0. Now the second case, we are going to see the second case, that x is equals to minus 3. And first we write the formula. The formula is limit x tends to c, f of x is equals to f of c. So here the given function is 5x minus 3, and now the case is x is equals to minus 3. So write the function in this limit x tends to c. So I will take first LHS. This is LHS. This part is LHS. F of x is equals to. Now I will write the function in the formula. So what is the f of x here? 5x minus 3. So I wrote here. Now what is c? C is minus 3, right? C is x tends to minus 3, 5x minus 3. Now I will substitute x value in the x place. So 5 into, when we write, after writing we remove this limit. So 5 into minus 3, minus 3. So 5 3 is a 15, minus 15 and minus 3. The value is minus 18. This is LHS. Now take RHS. What is RHS in this case? F of c. So I will write f of c. Here the function in x variable. Now I want to write the function in c variable. Why? Because here c in the x place. I replace x by c. So the function is 5 in the x place, write c, 5c minus 3. So I wrote. Now write the c value. Put c is equals to minus 3. So I will write here 5 into minus 3, minus 3. Minus 15 minus 3. It is minus 18. So in both the cases I got minus 18. Therefore LHS is equals to RHS. Hence f is continuous. F is continuous at c is equals to, what is the condition? Minus 3 condition. At c is equals to minus 3. So second case also over. Next, last case. What is the last case they gave? X equals to 5. So we will solve at this case f is continuous or not. We prove. So I will take third case. At x is equals to, what is the third case? At x equals to 5. And the given function f of x is equals to 5x minus 3. Now first write the formula. Limit x tends to c, f of x is equals to f of c. Now write the function here and c value. What is the c value here? 5. Limit x tends to 5. F of x, what is the function here? 5x minus 3. This is LHS. So I replace x value with 5. Why? Because x tends to 5. So 5 into 5 minus 3. So 25 minus 3, 25 minus 3, 22. Okay, next take RHS. Select RHS. What is the RHS here? So I will take, okay, I'll prove here. So RHS is equals to f of c. F of c. So what is the function here? 5c minus 3. What is c value? C value is 5. So write 5 into 5, 25 minus 3. So 22. Both are equal. LHS is equals to RHS. Therefore, f is continuous at x is equals to 5. So hence proved. So all the three cases, the first question, if we observe, the function is continuous at all these three cases. We proved. So now we go for the next question. Okay, sorry, I didn't see, I muted this. Again, I will explain. LHS we got 17. Now go for RHS. RHS is equals to f of c. F of c, what is the function here? 2, x is replaced by c, 2c square minus 1. Here c value, at which case it is x is equal to 3. So here c is 3. 2 into 3 square minus 1. So again 2 into 9 minus 1. That is 18 minus 1. That equals to 17. Now we got LHS, RHS both are same. LHS, therefore LHS is equals to RHS. Hence F is continuous. At the point where it is continuous, at x equals to 3. In this case, this function is continuous. So second problem also over. We will again discuss this second problem. They gave the function 2x square minus 1 and we need to prove, we will check whether it is continuous or not at the point 3. So first we will write the formula limit x tends to c, f of x is equals to f of c. So I will take LHS limit x tends to c, f of x. So it is LHS. So in this I will replace the values, the given values. Here f of x is 2x square minus 1. I wrote here. Then C is 3. Why? Because at x is equal to C. According to the formula I told in the beginning. So at x is equal to C means C is 3. I wrote here 3. Then I replace x by 3. So 2 into 3 square minus 1. So the value after simplification is 17. Now RHS here f of c. So take f of c, and what is f of x? We know f of x, the function in x variable. Now the function in c variable I want. That's why I replace x by c. I write c in the place of x. So 2c square minus 1. Here c value we know, that is 3. So I wrote c value here. Then again I will get 17. Therefore, we get same values for LHS and RHS. Therefore, LHS is equals to RHS. Hence, F is continuous at x equals to 3. I hope you are understanding. Then we go for the third problem. The third question is, the third question, examine the following functions for continuity. They gave examine the following functions for continuity. We'll check the first function. They gave a. First question is f of x is equals to x minus 5. Now, for this function, we are going to see whether it is continuous or not. First, we write the formula. Actually, they didn't give the point here. They didn't give c value. In this question, they didn't provide c value. But we will check the continuous for all real numbers. So I will take let C be a real number. I will consider here real numbers. So that's why I will take C be a real number. So next, I'll write the formula. Limit x tends to c, f of x is equals to f of c. So I'll take first this LHS. What is LHS? Limit x tends to c, f of x, and limit x tends to, I consider the real number is c. So I'll carry this c like that only. Then f of x, the function is x minus 5. This is the function. Now, I will write c in the place of x. X tends to c. So, c right in the place of x. C minus 5. So, it is LHS. Now, we take RHS. What is RHS here? F of c. I'll write f of c as RHS. So take RHS is equals to f of c. Now the given function in x variable, the function in x variable, now I want to write the function in c variable. I replace x by c. So c minus 5, or simply put x is equals to c in the function. So then c minus 5. What is LHS we got before? LHS is c minus 5 and RHS is c minus 5. Both are equal. Therefore, LHS is equals to RHS. Hence, f is continuous. Hence, f is continuous at c. C is what here? C belongs to real numbers. So, f is continuous for all real numbers in this case. So this is the solution for the 3a. Now next question 3b. I'll write next question. Three B. What is the 3b? F of x is equals to 1 by x minus 5. This is the function. And in the question they didn't give c value. So let us consider c be a real number. I will take c. It is a real number. C be a, for real numbers I am going to check. So c be a real number. The next right formula. Limit x tends to c. F of x is equals to f of c. Next, it is LHS. Take LHS. LHS is equals to limit x tends to c f of x. So I took LHS. In this I will write the function. What is the function? 1 by x minus 5. So I will write here limit x tends to c. F of x is 1 by x minus 5. Next, I will replace x by c. Here limit is x tends to c. So I will write c value in the place of x. Then I will get 1 by c minus 5. So it is LHS. Now take RHS. What is RHS here? This is RHS. F of c. F of c is the RHS. And the given function in terms of x variable. But I want to write RHS in terms of c variable. Simply put x is equals to c. So 1 by x is what? C. C minus 5. 1 by c minus 5, 1 by c minus 5. Both LHS, RHS are equal. LHS is equals to RHS. Since f is continuous, it is continuous at where it is continuous? At x equals to c. Here c belongs to real numbers. I told in the beginning I am taking for all real numbers. So that's why I took c as real number. So 3b also over. Okay, next 3c. Next question is 3c. The function is f of x is equals to x square minus 25 divided by x plus 5. So it is the given function. For this function, f is continuous at real numbers or not, I am going to check. So we know c be a real number. Then write the formula. Limit x tends to c. F of x is equals to f of c. Now take LHS. LHS is equals to limit x tends to c. F of x. F of x is x square. Can I write this x square minus 25 like x square minus 5 square? Can I write like this? So then it will become a square minus b square. What is the formula for this? A minus b into a plus b. I will use this formula here. So a minus b, x minus 5 into x plus 5. I used here a square minus b square formula and by x plus 5. So here x plus 5, here x plus 5 cancel. Now in the remaining function, I will write c in the place of x. So c minus 5, it is LHS. Next RHS. RHS is equals to, what is RHS here? It is the RHS, f of c. Now, what is the given function? The given function is x square minus 25 by x plus 5. It is in terms of x, but I want to write in terms of c. Put x is equals to c. So, here write c. C square minus 25 divided by c plus 5. So, same write here also. A square minus b square. A minus b into a plus b divided by c plus 5. Here cancel c plus 5, c plus 5. Then the solution is c minus 5. Now both are equal. LHS is c minus 5. RHS is also c minus 5. Therefore, LHS is equals to RHS. So, hence F is continuous. F is continuous for all real numbers. Okay. Next. Last 3D. In the third Roman, last question. That is, we will discuss now. Third question, the last question function is that is D, 3D. F of x is equals to determinant mod x minus 5. F of x is equals to mod x minus 5. We know the mod. What is the meaning of mod? For example, I'll tell about this mod. For example, I'm taking mod x is equals to a. Then I want to remove this mod. X is equals to plus or minus a. So we'll get plus when it is more than or equals to 0. We will get minus when it is less than 0. So by using this, we will solve this mod x minus 5. So first I will take mod x minus 5 going to divide it into plus or minus. So first I will write, I'm going to remove this mod. The first one is x minus 5 means plus x minus 5 I will take. Plus or minus is there. The meaning of mod is plus or minus. First I will take plus. Plus x minus 5 I will take. When it is plus, when this function means x minus 5 greater than or equals to 0. When it is greater than or equals to 0, at the time it is plus. Now next one, minus of x minus 5. When this function less than 0, at the time we take minus. Understand? From 0 to more than 0, positive numbers we will get. In the number line if we check, from 0 to more than 0, we will get positive numbers. So if we see the number line, 0. From 0 to more than 0, positive numbers. Less than 0, we get negative numbers. That's why I am taking 0. More than 0 is positive, and less than 0 is negative. So like that I divided the given function. divided into two parts. Now I will check for these cases. How many cases we are here? One is function is equal to case. Another is function is greater than case. One more is function is less than case. So one by one we will discuss. And I want to reduce once again this forms into plus x minus 5. For I will move this minus 5 to RHS side. Then it will get minus will become positive. So when x is greater than or equals to 5, two cases here. One is equal case, one is greater case. And next minus of x minus 5. This is, I'll move this minus 5 to that side. Then x less than 5. When it is less than 5, we will use this function. When it is equal or greater, we will use this case. I will write the cases one by one. Just carefully observe these cases. Here I have different values of x. So we need to check continuity. We check continuity for different values. For different values of x. For different values of x. If you observe here, we have different values of x. For these values, we will check the continuity of the function. So I will write the first case when x is equals to 5. I'll start with equals. So when x is equals to 5, one case. Second case, when x less than 5 case. When x less than 5, second case. And third case, here I missed one case, that is equal I took, but I didn't take greater than. Now I am going to take. So the last case is x greater than 5 case. So three cases are here. One is x equals to 5 case, another is x less than 5 case, one more is x greater than 5 case. Three cases I took. Then I will start with the first case. What is the first case? When x is equals to 5. So when x is equal to c, we have a formula LHS is equal LHL. LHL is equals to RHL is equals to f of c. Why I took this formula? Just listen. I will tell that reason. Suppose a numbers having 0, 1, 2, 3, 4, 5, 6. Our intention is the function is continuous or not at this 5. Means at this 5 it is continuous or not. How we say? Means before 5 there is points. The continuity means suppose the graph like this. The graph is like this. So the graph is, the waveform is coming like this and it is touches the 5. Before 5 points are not checked. Suppose after 5 there is no points, means it is not continuous. It is stopped at 5 only. So at this point it is stopped. Means it is discontinuous at 5. But we are going to see continuity. So that's why after 5 also the points are there. The meaning of this one is 5 before, means left hand limit and right hand limit equals to 5. The meaning is 5 before, suppose I am taking 4.9999 and 5 after, in middle 5 and 5 after 5.001 something, 1, 2, so or 5.1. So when 5.1 is there and 4.9999 is there, it is approximately, this value approximately equals to 5 and this value approximately 5. means 3. When 3 are equals, then it is continuous. That's why we will take limit before value, that is left hand side value, this limit after value, that is right hand side limit, left hand, right hand, and this exact C. When 3 are equal, then it is continuous. Can you understand this? Is it okay? Are you understanding this? Exactly at this point means before point and after point, 3 points are when equal, then it is continuous. Okay, so based on this we will start that problem. So what is the formula? Exactly equals to 5 means LHL is equals to RHL is equals to F of C. So LHL, left hand limit, not LHS. Observe, left hand side is different. LHS, before I used LHS. S means side. Here I will use LHL. L is left hand limit. Actually 5 is the limit. For 5, left hand limit means for this limit left hand side, left hand the meaning. And for this limit right hand. So LHL is equals to, so I will write the LHL formula, limit 5, for 5, what is the LHL value? Means left hand side value is 5 minus, correct? 5 before is 5 minus. 5 after is 5 plus. Keep in mind, 5 before means less of 5, 5 minus. After 5, more of 5. So that's why 5 plus. So based on this, I will make formula, limit extends to, it is left hand, so 5 minus, I'll write like this, into f of function x, function right, f of x. So this is LHL. Suppose RHL I want to write, the same we will write, but here 5 plus we take. Why? Because after 5 is RHL, that is 5 plus for RHL. Here it is LHL, we are taking 5 minus. Now I will write these values. And RHL I will write once again, listen. RHL is equals to, what is RHL? Limit extends to 5 plus f of x. And LHL I wrote, RHL I wrote, then f of c. F of c is what? Simply I will write c value. What is c value in this? 5. Exact value. I will write here. Now we need to get all 3 values are equal. If all 3 values are equal, then this is continuous. Understand? So first I will start with the LHL. LHL is equals to limit, actually 5 minus. 5 minus means we start from the x, the point is 5 minus. Where it is, I don't know exactly. That's why I start from 0. I start from here means, so right, I'll change the variable x as h. H tends to 0. F of, here x is there. X I am going to replace by, here what is x tends to? 5 minus. So I will write 5 minus. Here in the x plus what I wrote? H. So this is the formula. Suppose in the RHL, how can I write the same formula in the RHL? I will check. I will start with 0. H tends to 0. F of x is going to replace by, x tends to 5 plus I told. So 5 plus, in the x plus what is there? H. Variable is h. So 5 plus h. Now I will solve this LHL. LHL is limit h tends to 0. F of 5 minus h. So this is the LHL. Now I will write the function. Limit h tends to 0. F of x. What is f of x? What is the function? The function is at x is equals to 5. At equals to 5, what is the function? X minus 5. So write this function, x minus 5. So it is x minus 5. The function is x minus 5, but x is what here? 5 minus h. So in the x place, write this 5 minus h. 5 minus h, I wrote in the x place. Remaining is minus 5. Now plus 5, minus 5, cancel. Limit h tends to 0. What is the remaining? Minus h. Now finally, write this 0 value in this h place. Then we get 0. So LHL is 0. Now go for the RHL. What is RHL value? We will check. I told here. What is RHS? RHL. RHL is limit h tends to 0 f of 5 plus h. Here f of x. F of x is what? At x equals to 5. X minus 5. So x minus 5. But what is x here? X is 5 plus h. So I will replace this 5 plus h in the place of x. So 5 plus h minus 5. I will cancel plus 5 minus 5. The remaining is limit h tends to 0 h. So now write h tends to 0. 0 in the place of h. So 0. This value also 0. LHL is 0 and RHL also 0. Then last one, the remaining, what is the last one? F of C. So if f of C also 0, then it is continuous. So we will find f of C. F of C. C is directly 5. So I will write this exact 5 value in this C place. So what is the function? The function is x minus 5. So x minus 5. But in the x place what we have? 5. So write here 5. So 5 minus 5. 5 minus 5 is 0. Can you get idea about now? All are having zeros. So LHL is 0. Or HL is 0. And f of C also 0. Now all are equal. LHL is equals to RHL is equals to f of 5. Therefore, f is continuous. F is continuous at what point? At x is equals to 5 point. So at first case, what is the first case? At x equals to 5, f is continuous. It is valid. Next, go for the next. Next case is when x less than 5. When x less than 5, we will check. X less than 5 means where we get? Here we get. It is x less than 5. At that time, what is the function? Minus of x minus 5. So I will write that second case. Second case is at x less than 5. So at x less than 5, so the function, what is the function at that time? F of x is equals to minus of x minus 5. So this is the function. Now, if you observe here, in this no numbers, means less means there is no RHL. There is no equal. No need to write that LHL is equals to RHL is equals to f of C. Why? Because it is not equal. It is less symbol, inequality symbol. So for inequality symbol, don't take LHL is equal to RHL is equal to f of C, that formula. So you directly take this f of x. Now, if I take this directly f of x function, it is in the form of minus x plus 5. It is polynomial. It is polynomial. When the function is polynomial, then it is continuous. When the function is polynomial, f is continuous. So very important. So when the function is polynomial, then automatically it is continuous. Next case and last case. What is the last case in this? X greater than 5. So when x greater than 5, at that time what is the function? Plus of x minus 5. So we'll take plus x minus 5. This case, at x greater than 5, f of x is equals to x minus 5. So it is also greater than, it's not equal. No need to write LHL is equals to RHL is equals to f of c. So directly we take x minus 5. Now tell me, is it polynomial or not? Therefore it is polynomial. Hence f is continuous. F is continuous. Okay. So for 3 cases, it is continuous. If you observe, for all these 3 cases, it is continuous. So final conclusion is f is continuous at all real numbers. It is continuous for all the cases. So it is continuous for all real numbers. So this question is over. I hope you are understanding. If any doubts, please comment me. I'll clear your doubt now. Okay, I think no one has doubt. You're understanding well. We will continue this class tomorrow. Now we will close this class now.